We're going to make a car agent from scratch that can drive quickly around this track, which is a lane. We start with new agent, change the name to car, page down to get to the body page, change the segment name to box, and change the segment type to box. And now we can set the size to 2 meters wide, 1.2 meters tall, and 4 meters long, with an offset of 0.7 meters in Y. With Alt 2 we can switch to camera 2 and see that we've got something vaguely the shape and size of a car. Back to camera 1 with Alt 1. Now page down we get to the brain and there's nothing there, so let's bring on an output node and set it to TZ with a range of 100. That's 100 meters per second, and set the output value to 20. Now let's see what happens if we hit the spacebar. Well, it goes forwards, but it doesn't follow the lane because there's nothing in the brain to tell it to follow the lane. Let's copy and paste the brain from the previous tutorial. We just need to make one slight adjustment, and that is because the output was controlling the RY curve of the action, and there's no action now, so we can control RY directly. Let's see what happens. Well, it kind of follows the lane, but it's not turning sharply enough, and that's probably because this was set up for walking. Let's change the range of the output node to -360 to 360 and set the defuzz values to the limits and see what that gives us. Right, that's good, but it's a bit boring. Let's make him go faster. Let's try 60 meters per second. Oh dear, okay, now he's completely lost the plot. Well, how can we improve this? It's possible to have the agent respond to the lane slightly ahead of where it is, and that might be useful. So if we click on a lane input node, we'll see that there's a look ahead down here in the corner. Rather than set that directly, it's better to use another input, and if we alt connect to these two lane input nodes, we can set the look ahead value, and let's change this to look ahead, set the value to 0.2 seconds. Now let's see what happens. Right, well, it turns more appropriately, but it does wiggle a bit, and that's because the turning is based on the look ahead, but the look ahead is based on the turning, which means it's kind of chaotic, and we can fix that just by filtering the RY output with 0.1 seconds. Now it's nice and smooth. Alright, but I think we can do better than that. Let's adjust the speed according to how much it wants to turn. We get a couple of defuzz nodes. Call this one slow. Call this one fast. Connect those up. And make the fast the default by clicking on else and set the value to say 70. Now we get an OR node, and we can OR the conditions where the agent needs to turn sharply. That should be enough, and connect that to slow. Now what happens? Okay, well, it does sort of slow down a bit when it sees a sharp corner ahead, but it's a bit jerky, and that's not surprising because the input information to this node is sort of a bit jerky. So once again, we can smooth this out a little bit by using the filter. So let's set that to say 0.5. Okay, now we've got a little bit of smooth adjustment of the speed of the car. And another side effect of this is if we start again with Alt R, our car smoothly accelerates from 0. What else can we do? Let's bring on another input node, set it to RY, which means we're getting the rotation of the car as an input, and give it the same range as the RY output. Get a couple of fuzz nodes, call this one left and this one right. Connect those up, and left is a positive value, and right is a negative value. Let's get some defuzz nodes, call them left 0 and right, and an output node. Connect those together. Now we'll control the segment, and there is only one, so select that and RY. Now this is different from the agent RY. This just rotates the segment within agent space. We can connect these, and we need to give this a range. Let's go -45 to 45, left and right. And did we make this an else? We need to set this to an else, because a lot of the time there won't be anything being set here, so there needs to be something to give us a sensible value when neither left nor right are active. Let's see what happens now. Okay, our car sort of spins out on the curves, but it gets a little bit flicky here and there. Let's have a look at our input data. Well, it's swinging wildly from side to side, so there's not much we can do to smooth out the fuzz values. So once again, this might be a case of using a subtle output filter. And again, we'll use 0.5 seconds. Right, now we've got our car drifting around the track.